operations with radical functions. We have two properties we're going to be talking about today, the product property and the quotient property, which are basically just inverses of each other, correct? Okay, so if we have the square root of 2 times the square root of 8, that would be, I can't simplify the square root of 2, but I could simplify this one, it's 2 root 2. But isn't it easier if we just multiply them together and make 16, which is 4 squared, which is just 4. Okay? You can do that either way. No notes yet, you guys. You really need to. I was talking with a coach about it. He said that I said Algebra 2 hates not taking notes while I'm talking. And he said they just don't understand when you write and you listen, you are not hearing everything. I will give you plenty of time to write this stuff down, I promise. I just need you to listen. Okay, so same thing can happen here. This would be the cubed root of 27, which is really 3 cubed, which is really 3. Same thing with the quotient. I can treat the numerator and the denominator separately, or I can treat them together, which is 54 over 2, which is the cubed root of 27, which we just found out is 3. Believe it or not, besides these cubed roots, this is all 7th grade math. Right? Some of you, I taught this to you. Okay. Oh yes, I am going to let you write it down. Sorry. Thank you for reminding me. I just said I promised, and then I changed the screen. Okay, write that down, guys. Make sure you have all. Okay. So definitely pencils down. I'm going to give you time to write all these steps down. Okay, so let's start with this first one. If it doesn't have anything here, then it's automatically a square root, right? So this one would be 5 squared. I'm just going to, if I have room to write, I'm just going to write them out, okay? So this would be a squared times a squared. Keep writing this down. And b squared, b squared, b squared, b. Correct? 2, 4, 6. Total of 7? Nope, need more. 8. There's 9. Okay, so how many? We've got 1 5. 2 a's get kicked out, correct? How many b's get kicked out? 4, and 1 is left underneath that radical sign. Do I need any absolute value? No. That's squared. Could it ever be negative? Nope. That's to the 4th. Could it ever be negative? Nope. Don't have to worry about it, right? Putting absolute value around it would just be redundant. You know what I'm saying? That one's not simplified. That one just stays by itself. You don't have to worry about absolute value underneath a radical sign. Well, I look at this. Look at your answer, because it doesn't matter what this is. It matters what the answer is, right? So if this is odd to an even, then you have a problem. If any one of these was odd, we'd have to think about whether we need to do absolute value. For instance, if it was a b cubed, let's look at that scenario. A is odd. That's kind of, that one's in danger, right? It could be negative, it could be positive. A was originally to the 4th. Okay? Could that be negative in there? It could be. So we better put absolute value around that guy. B cubed. That could also be negative, right? It was originally negative. So is it negative at all? No. Odd, odd, no problem. Odd, even, problem. Even down here, not a problem. If it's even here, there's no way it could be negative. Is that starting to sink in a little bit? I think you just need practice doing it. I really do. That's why I'm not continuing the lesson beyond this today. Okay? Oh no, it's getting more difficult right here. But I'm not, I mean, I have a lot of other stuff to do, like adding radicals. We're not even going to touch adding radicals today. We're just going to do this. Okay, just simplifying radicals that are being multiplied and divided. That's it. All right, so let's do this one. So that's my answer right there. I'm done. Okay, so this one, I think I'm going to change color when I do numerator and denominator on these, because it kind of ran together in the last class. So I have, if this is a radical underneath, a fraction underneath a radical sign, I can also rewrite it, correct? Because it being a fraction, is that helping it at all right now? I've got y's in the numerator, x's in the denominator. Can you cancel any of those? No, so we might as well treat them separately, right? So I might as well say I've got y to the 8th in the numerator and x to the 7th in the denominator. Now let's talk about y to the 8th. Y to the 8th is really y squared how many times? 4 times. And x to the 7th is x squared how many times? 3 with 1 left over. All right, everybody follow? So what gets kicked out in the numerator? Y how many times? To the 4th. And in the denominator, x gets kicked out how many times? With what left over? Now what's wrong with this? There can't be a radical in a denominator. So I'm forced to multiply by root x. When I do that, I get, in my numerator, y to the 4th root x, and in the denominator, I get x cubed times the square root of x squared, right? There's 2 of them now. Well, doesn't that get kicked out? So now you just have y to the 4th root x over how many x's? X to the 4th. Right? Because I had 3, and then I have another one, so now I have 4. Let's go back and look at this. X to the 4th, can that ever be negative? No, so we don't have to worry about it. Y to the 4th can never be negative. We don't have to worry about it. Okay, let me do the last one, then I'll take questions and let you guys write all this down. Okay? So this one's cubed root. I know this is not, they're not helping each other at all, so I'm just going to say, change my color again. I have the cubed root of 2 and the cubed root of, I'm going to change this to a 3. 3 squared times x. Are we with me so far? Can I simplify any of this? No. Therefore, I have to worry about the fact that there is a radical in the bottom. I need to get rid of the radical. What would I multiply by to get rid of the radical? That would give me x squared. Is that going to help me out? It's a cubed root. I need 3 of them. So don't I need 2 x's to make a total of 3 x's? Right? What else do I need? I need 1 more 3. See how that was done? Now I have, let's do the denominator first, yeah? Now I have, these are cubed roots, I have 3 3's and 3 x's. See that? 3 3's, 3 x's. What do I have in the numerator when you multiply both of those? 6x squared. I can't simplify any of that. It's just going to stay there. However, I can simplify this. It becomes, rewrite all of this, the cubed root of 6x squared all over 3x. X is odd, right? It was originally odd. So do I have to worry about it? Nope. Go ahead and write this down. Oh, let's go back and look at this. These are not steps as much as guidelines. So when simplifying radicals, you must think about these things. Factor the radicand into as many squares as possible, or cubes. You know, you want to simplify as many as you can out. Use the product property to isolate perfect squares, or the quotient property. They're inverses of each other. They have the same rules. That's why I didn't write both of them. The radicand contains no fractions. The radicand is what's underneath it. So this is not simplified. You can't have fractions. Okay? The reason you can't have a fraction is because it's equivalent to this, and this you can't have in the denominator. Right? Does that make sense? No radicals appear in the denominator. That's what I just said. And apply absolute value signs when necessary. So make sure you've got all of your guidelines down and write these examples down. Then we're going to do 3 more together. 3 more on your own, and I'll give you the answers. And then that's where we're going to stop today. Okay, so let's look at something really important here. Let's say we had x times y, x over y, times 2 over z. How would I do that? Multiply straight across, right? That's 2x over yz. When does that game change? When can I not just multiply straight across? When it's adding. As soon as you see addition, the game changes. And this is what Cassandra was asking me. It's when you have something like this, like that. Is that what you're talking about? That's when you would multiply by the reciprocal. Exactly. In fact, that's part of the lesson today that I'm not going to teach, because that's what this homework is right here. I'm not even going to go that far today. Because if you guys can't get solid on this, it doesn't even matter if I go to the next step, because you're not going to get that either. You know what I mean? So I thought we would just stay solid with what we're doing today. Agreed? Yes. Okay, so this is, forget this. Forget that right now. All we have is this right here. Okay, and we're going to forget. This kind of makes it easier. When it's white, you really forget. Otherwise, you're like, it's really there, we just can't see it. Okay. So, does this make sense here, that this is this? It doesn't. I see what you mean by I skipped a step now. You're right, I'm wrong.
I told you.
This is really, I'd see, and I'm glad you should have pushed the point a little bit more.
Yeah, and then you tricked me into thinking that I was wrong.
I assumed, which is wrong, that all of you saw this. Does that make sense now? Right? Then, I can't do anything with this, right, because there's not 3 of them, so it just stays in there. And I can't do anything with the other one either, but I might as well write it in a form that shows me how many I need. So 9 is really 3 squared times x, correct? So how many more 3's do I need before I've got 3 of them? 1 more. And how many x's do I need before I have 3 of them? 2. That is why I multiplied my equation by a 3x squared, because now I'm going to have 3 3's and 3 x's, because if I have 3 3's and 3 x's, there won't be I won't need a radical sign anymore. And that's when we came down to this. Something happened. I don't have anything covering it. I don't know what that is. Okay. So now I have, it's supposed to be a 3. Thank you. So now I have in the numerator, right, because 3 or 2 cubed here. Now it's all bunched up. 2 times 3x squared is 6x squared. Still can't do anything with that. And then in the denominator, right here, this might help. This is what I'm multiplying in the denominator, right? I'm multiplying that times that, which is 3 cubed x cubed. You don't want to multiply by more than you need. Let's look at this. What if I did this? This would be your natural. Let's make this real nice and easy. Let's just put a 1 on top. Isn't your natural instinct to do this? How many of you originally said, oh, I'm just going to multiply by exactly what it is? Right? Well, if I did that, wouldn't I get, how many 3's would I have? More than that. 9 times 9, I would have 4. Right? And I would have x squared. Is that going to help me? What gets kicked out of this? 1 3, and I would still have a 3 left over and an x squared. I still have a radical in the denominator. You know what I mean? I have to multiply by something that would remove the radical sign. Therefore, I need to multiply by whatever multiples I need to make 3 of them. I have 2. How many do I need? 1 more. What if this was to the 4th root? How many would I have needed? 2 of them. I think we just need to practice. I really do. I think this is one of those things where you look at it, and it's not going to make sense to you until you get in there and get your hands dirty and do it yourself. That's why as soon as I started talking about this in the second period, and these little looks I got, I said, you know what? I don't need to go any further than this. They just need to practice this. Right? Okay. So why don't you guys try these on your own? I'll give you, oh wait, have you written all of this down yet?
Yeah.
Okay. That's right, Dan? That's right, because I went through all the homework writing. So you guys do these 3 on your own, then I will give you the answers, and you can see if you got them right or where you made your mistake, because that's where you learn. You don't learn by getting things right. You learn by getting things wrong and then figuring out how to fix it, right? Because getting things right isn't really learning, it's just knowing. You know what I mean? If I gave you a test that was from 7th grade math, would that test you on anything that you learned this year? No. It would test you on everything you know. Never mind. Okay. I'm not sure I understand myself right now. Okay, guys, forget those.